The final part in getting a cheap ZVS induction heater ready to heat a workpiece is getting a work coil that's designed for the workpiece that's going to be heated. Arguably, the most important factor of a coil is the inductance of the coil, because that determines the operating frequency of the ZVS oscillator. And the operating frequency determines whether or not the components can actually hang with what you're doing. If you get the frequency too high, these MOSFETs are eventually going to pop. If the frequency is too low, these coils get stressed. And ultimately, the components on the ZVS are not designed to work at just any frequency. So it's a good idea to match the inductance of the coil that you're using with the inductance that the ZVS came with. I put a reasonable approximation of the inductance of the working coil behind me, but in reality, if I'm actually sitting there winding coils, I'm going to go online and I'm going to use an inductance calculator so that I don't have to punch in numbers over and over. It's just going to be faster that way. For the coil that came with my induction heater, there are 1, 2, 3, 4, 5, 6, 7 turns. So N in that equation is going to be equal to 7. Also, I should mention the formula behind me is in inches. The radius of this coil that came with my ZVS is half of 1.78 inches, and the length is 2.1 inches. So when I punch that all into the calculator, I get 1.34 microhenries. That's going to be my goal for the coil that I'm designing. Again, there's a lot of stuff that goes into a coil that this doesn't take into account. These are approximations. The next thing I'm going to do is find something that I can use as a mandrel that's about the size of the workpiece. I want to get the coil close to the size of the workpiece so that the energy transfers better. For my thin-walled brass tube, this Sharpie is going to work out at least for 14 gauge wire, which is the coil that I'm first winding. When I'm winding the coil, I'm going to look at how much of the workpiece I want to anneal. Now the gauge of wire does matter. In fact, it matters a lot, mostly because of the resistance of the wire. Wire that has a smaller gauge is going to have a higher resistance and it's going to heat up worse. You're not going to be able to do one workpiece right after the other if you're using something as flimsy as 14 gauge wire. So that looks like about the amount of tube that I want to anneal. The next step I'm going to do is I'm going to see where I'm at so far with the inductance of this coil by measuring the same dimensions and plugging them back into that equation. So for that first layer of this coil, I got 0.29 microhenries. So I've still got a ways to go. Now, you'll notice from that equation that the bigger around I make the coil, the more inductance it's going to have. So when I wrap a second layer around the outside, I should also mention that I'm literally just taking each one of these coils and I'm going each one of these layers and adding them up, because inductance adds up in series. Now I know there's going to be some electromagnetic effects of having one coil wrapped inside the other coil, but again, this is an approximation. I couldn't find an equation where you could actually vary the space in between two coils that were going around the same core, and so that's what I use for an approximation. When I've got the first couple of coils wrapped and I see sort of how the wire wants to bend, I measure that and then I figure out how many more turns I need to add to get the inductance that I want, which in my case is going to be about a microhenry. And again, this is just doing the same measurements as before and then plugging them into that equation. You'll have to assume things for the length. Like for instance, if I look really close at that, I can see how much length there is in this section of the coil, so I can take that and just plug in a couple different values. Just assume that it's going to be that about that spacing going up the coil. So for the second layer, I've got about 1.07 microhenries, giving me a total of about 1.36 microhenries. So that's close enough. Again, with 14 gauge wire, I'm not really holding out much hope of this being able to do long runs, but for some applications it might work if I'm only going to be heating a workpiece for a quarter of a second or something like that. So let's test it out and see what happens. So here's the setup. Got that coil hanging in there. And I've got this delay set on 1 second. The reason I waited until the last minute is because if this messes up, I want it to turn off automatically. Here we go. Well, we got some grease burned off of that coil, but let's see if it's warm. It's remarkably warm, so I'm going to let it sit for a minute, and I'm going to get one of those little brass tubes and put it in. For the first test, I set the brass on a breadboard so it wouldn't burn what it was sitting on. With the time set for a second, I was able to burn off some oils from the surface of the tube. I let everything cool and increased the time to 2 seconds. The coil got hot enough to tarnish, and the tip of the tube just barely started to glow. While this shows that it's possible to use 14 gauge wire to anneal a thin-walled tube with this setup, it also shows it isn't efficient. Any power that heats that coil is wasted and might damage it. Since I was fairly sure the brass would fail before the coil, I increased the time to 3 seconds and melted the brass tube. Winding a coil out of 8 gauge wire wasn't particularly difficult, but it required a better mandrel than a Sharpie. I threw together a base for the induction heater and attached it to the heater circuit using the ground bus bar for an electrical box. The trickiest part was aligning the coil. Since I didn't want to handle hot workpieces, I used a Dremel to modify the relay wiring and connected a door lock popper to a trap door. Everything is controlled by the microcontroller. With the 8 gauge coil, the rim of the workpiece got red hot inside a second. That concludes this video series on how to get a ZVS going for under 70 bucks. If you would like more information, be sure to like and subscribe. It's even easier than voting.